we learned about the line of the proportional relationships always pass through the origin, right? So what we're going to try with this question is we're going to interpret the graph of a proportional relationship, and everyone see that, oh, the line passed through the origin. So this distance and time, the relationship between these two are proportional. So the distance and time, they're changing proportionally. So now, how can you interpret this 0, 0, and 1 and 1.5, and 3, 4.5? So this 0, 0 means that the rover travels, okay, the rover travels, I need you to copy all down, travels 0 inches in how many seconds? 0 seconds. It doesn't go anywhere. 0 second. Okay, 0 seconds. And what about 1 and 1.5? For 1 second, it travels how many miles? How many inches? 1.5 inches. So it travels 1.5 inches in how many seconds? 1 second. So the unit rate, you can find the unit rate here, right? Because it says per 1 second. So this guy is going to be the unit rate. So if you have a graph per 1, that value, which is 1.5, this guy is going to be the unit rate. So if you have a graph, actually things are getting easier. What about 3 and 4.5? 3 seconds and 4.5 inches. It means it travels. You have to keep copying the same thing, like my song. 4.5 inches in how many minutes? How many seconds? 3 seconds. And we know that as you see X's and Y, seconds, the time and distance are proportional. So you can also use these numbers to find the unit rate. So you know that 4.5 over 3 and per 1, what is it? But we already find the unit rate, but you can also use this point to find the unit rate when the variables are changing proportionally, okay? But we already know per 1, so you don't need to worry about the unit rate. But you can also use this, but you will get the same unit rate from the second point. So I'm going to put the unit rate at the bottom. Unit rate for this situation is going to be 1.5 inches per 1 second. Okay, we're going to interpret, and we already know that this is a proportional relationship because the line passes through the origin, right? Origin. It passed through the origin, which means it's a proportional relationship. Okay. So 0, 0 means what? If you look at the variables for y, it's earning dollars. I guess someone is working, right? So if you work for 0 hours, this is hours, right? So you earn how much you earn? You earned $0 for 0 hours of working, right? 0 hours of working. And for 1 hour, how much you will earn? You will earn 15. So you will earn $15 for 1 hour of working. 1 hour. So some of you already found that, like, oh, this is going to be the unit rate because we're talking about per 1 hour, right? So $15 is going to be the unit rate. And what about 4 and 60, which means you work for how many hours? 4 hours. So you earn how many? $60 for how many hours of working? 4 hours of working. So you can also use this to find a unit rate, or you can just find, oh, how much is going to be per 1 hour. Then you will find the unit rate right away. Or you can also use any other points of this line because it's a proportionally changing. So it doesn't matter. Everything should give you the same unit rate, okay? All the points will give you the same unit rate. All right, let's check the variables. The first one is height. And second, I guess you're on there's a title here, hot air balloon. So 0 means what? For 0 seconds, how many heights you can go up? It's 0 feet, right? So you will go up to up by one zero foot for how many seconds? 0 seconds. So in 0 seconds you don't go anywhere, right? What about 1.5? 1.5, you go up by 5 feet in 1 second. And as you see, the height and seconds are changing proportionally, right? So you can say 5 feet per 1 second. This is going to be the unit rate. 5 is going to be the unit rate. This guy is going to be the unit rate. And also here, 5. And you go up by, you go up to 30 feet in 6 seconds. So you can also divide it by 6 to find the unit rate. Then you will also get 5 feet per second. So the unit rate, you just find the unit rate, and then if you copy this down, if you show all work on the quiz or test, then you should be good. So there's nothing on the graph. Let's put a scale first. So it is 1 to 10. So I think we can go up by 10. And then, so 0, let's see, 0, 1, 2, 3, 4, 5, 8, 9, 10. Okay, so what about, it's going up to 50. So let's go up by 10. So 10, 20, 30, 40, and 50. And this is going to be y, this is going to be x. Okay, the first one, 1, 5 here. And 420, 420, and 7, 735, 7 and 35, it's here. And 10 and 50. Okay, so it should be up here. So if you connect it, I think this is going through the origin, but let's double check. Let's double check too by simplifying all the ratios, 7 to 35 and 10 to 5, 10 to 50. So it's going to be 1/5, and this is going to be 1/5, 1/5, and 1/5. So it should go through the origin, right? It should go through the origin. And you can say x and y are proportional. Because you can also say they're all having the same equivalent ratio, or because you can say the line passes through the origin. And the unit rate, it's per one hour. How many feet you travel? It's going to be 5 feet per 1 hour. This is a unit rate. As you see, it doesn't pass the